We gaze up, breathless, at the velvet blackness, and there it hangs, a ghostly spiral, an entire universe of stars. Andromeda, our nearest galactic neighbor, a colossal cosmic island, 2.5 million light-years away, a distance that doesn't just stretch, it devours imagination. We dream, don't we, of bridging that impossible void, of shattering the barrier, of stepping onto alien shores, light-years beyond our own. But what if the universe itself has already slammed shut the doors? Not just with unthinkable distance, but with a cruel, elegant trick of physics we can never, ever escape. The audacious dreams we harbor, the yearning to touch alien stars, to walk on worlds orbiting suns in entirely different galaxies, they all come crashing down against the universe's most unyielding, most merciless decree. Not a wall of ice, not a ring of fire, but something far more fundamental, woven into the very fabric of space-time, the cosmic speed limit. We're talking about the speed of light. It isn't just a number on a cosmic speedometer. It is the absolute bedrock of reality, an unbreakable barrier, a divine edict etched into existence itself, a law so fundamental that even the most powerful forces in the cosmos bow before it. Nothing, absolutely nothing, can travel faster. Not a whispered thought, not a desperate signal, not even the most audacious starship humanity could ever conceive, bristling with every ounce of our technological might. Imagine for a moment that we could build such a vessel, a shimmering spear of impossible alloys, hurtling through the terrifying vacuum at 99.999% the speed of light, a fraction so infinitesimally close to the ultimate limit it might as well be light speed. Even then, the journey to Andromeda, our colossal swirling galactic neighbor, a mere cosmic stone's throw away in the grand scheme of things, would demand an agonizing 2.5 million years. 2.5 million years. Let that number not just echo, but resonate through the deepest chambers of your mind. That isn't just a journey, it's a geological epoch, a span of time so vast, it dwarfs the entire recorded history of human civilization into a mere flickering candle in the heart of a solar flare. Think of it, 2.5 million years ago, our ancestors were still sharpening crude stones, not building spacefaring behemoths. The Earth itself was a vastly different place, barely recognizable. For a theoretical crew on such a ship, Einstein's theory of relativity might offer a cruel theoretical solace: time dilation. Perhaps from their perspective, only a few decades would crawl by. They might arrive, still vibrant, still breathing, their bodies barely aged. But what about the universe they left behind? The cosmic clock back home would have relentlessly churned forward, ticking off 2.5 million years. Their home planet, their entire civilization, would be an ancient, distant memory, perhaps even dust in the cosmic winds, their languages forgotten, their monuments crumbled, their mission a forgotten footnote in a history they could never rejoin. The very stars they aimed for might have changed, evolved, or even died, their light reaching the destination only after the ship arrived. This isn't a problem of engineering, it's a problem of existence. It's like being handed a cosmic credit card with an infinite limit, but told you can only spend 1 cent per century. The wealth of destinations is there. The celestial treasures are visible, tantalizingly, within sight. But the rate of travel, the absolute, unyielding constraint of light speed, renders the entire enterprise a monument to futility. The speed of light isn't just a hurdle, it's a gravitational well, a temporal prison, an invisible force field that ensures that while the universe expands, our reach remains horrifyingly, painfully, fundamentally finite. It's the universe's first and most brutal alibi against our escape. We are locked in, not by physical chains, but by the very speed of light itself, a cosmic jail cell that shrinks our grandest ambitions to dust. If the universal speed limit wasn't a cruel enough joke, a cosmic handcuff binding our interstellar ambitions, then prepare for the punchline. Because the cosmos isn't just vast, it's alive, it's breathing, expanding, and in its most terrifying act of cosmic indifference, it's accelerating. This isn't merely distant galaxies receding from us like ships sailing over the horizon. No, this is something far more profound, far more insidious. The very fabric of space-time itself is stretching relentlessly, between every point in the universe. Imagine a colossal, infinitely thin rubber sheet, pulled taut and then stretched even further, faster and faster in all directions. Every galaxy, every star, every atom is a speck of glitter glued to that sheet. The glitter isn't moving across the sheet. The sheet itself is expanding, pulling the specks apart. And here's the mind-bending twist. The further apart two specks are, the more sheet there is between them, and thus, the faster that intervening space stretches. This means that distant galaxies are not just moving away from us. The space between us and them is expanding so rapidly that beyond a certain cosmic boundary, they are effectively being carried away from us faster than light can travel. Let that sink in. Not through space. Faster than light. That's forbidden by Einstein. But with space, dragged along by the very expansion of the cosmos, it's like being on a cosmic treadmill where the belt speeds up the further you are from the starting line. At some point, the belt is moving so fast that even if you sprinted at the speed of light, you'd never catch up to the objects racing ahead. This isn't theoretical doom. It's a fundamental, chilling reality. It creates an ultimate, invisible boundary around us, our cosmic horizon, a sphere beyond which galaxies are already racing away so fast. Their light, their very existence, will never reach us. They have already slipped over the edge, forever lost, forever unreachable. They are still there, vast islands of stars, perhaps teeming with their own life, but to us, they are effectively gone, sealed off by an ever-accelerating cosmic speed limit that applies to the very fabric of reality. This isn't a future possibility, it's a present catastrophe. There are already countless galaxies, vibrant with stars and perhaps life, that have crossed this threshold. We see their ancient light, a last desperate gasp from a time when they were closer, before space itself devoured the connection. But any future light they emit, any desperate signal of their existence, will never reach us. They are already beyond our grasp, sealed off by an accelerating cosmic void that ensures we are forever trapped within our own observable bubble. It's the ultimate cosmic joke, isn't it? We crave to explore, to reach out, to touch the infinite, and the universe, with a chilling smile, simply stretches the path faster and faster until the destination slips away, forever out of reach. If your mind is reeling, stretched like the very fabric of space-time itself by this revelation, then you're beginning to grasp the true scale of our cosmic predicament. And if you want to keep unraveling these mind-bending secrets of the cosmos, then smash that like button and subscribe, because we're just getting started. The accelerating expansion isn't just a theoretical construct, a line on a graph. It's a cosmic eraser, slowly but inevitably wiping away vast swaths of the universe from our view. We are already witnessing the earliest, most terrifying stages of this process. Imagine gazing at the deepest reaches of the night sky, peering through our most powerful telescopes and seeing not just distant galaxies, but the ghosts of galaxies. These aren't actual apparitions. They are the last fading echoes of light from cosmic islands that are already right now beyond our reach. Think of a ship sailing away from you on a turbulent, endless ocean. At first, you see its full mast, its sails, its crew. Then, as it crests the horizon, only the mast is visible. Soon, even that disappears. Not because the ship vanished, but because the curvature of the Earth, like the accelerating expansion of space, has hidden it from view. Now amplify that to cosmic scales, with the very ocean itself stretching and pulling the ship away faster and faster. Every photon of light that leaves a distant galaxy is racing towards us, but the space it must traverse is simultaneously expanding. For galaxies beyond a certain critical distance, a boundary known as the Hubble sphere, the expansion of space is so rapid that the light emitted by those galaxies is literally being carried away from us faster than it can travel towards us. It's like trying to walk upstream against a current that's moving faster than you can possibly walk. You'll never reach the source. The light will never reach us. What does this mean for the cosmos we observe? It means that galaxies, once bright beacons in the early universe, are slowly, silently, crossing this cosmic event horizon. Their light, once visible, will eventually become so redshifted so stretched by the expanding fabric of space-time that it will fade into an imperceptible whisper, then vanish entirely. These will become our ghost galaxies. They haven't exploded. They haven't collapsed. They haven't ceased to exist. They have simply sailed over the edge of our observable universe forever. This isn't some distant, theoretical apocalypse. Billions of years from now, it's happening right now. The light from some of the most distant galaxies we currently observe, those faint smudges in the deepest fields of the James Webb Space Telescope, represents the very last photons that will ever reach us from those cosmic entities. Any light they emit today, right this second, is already doomed to travel forever, stretching and stretching, never quite reaching our corner of the cosmos. They are already beyond our cosmic event horizon, their future light forever trapped in the accelerating void. The universe is literally becoming emptier, not because stars are dying, but because the space between us and everything else is expanding so rapidly that the vast majority of galaxies are being carried away from us faster than light. In a few billion years, the night sky will be a vastly different place. The familiar spirals and ellipticals we marvel at today will be fewer, fainter, and eventually gone. Our local group of galaxies, the Milky Way, Andromeda, and their smaller companions, will merge into one grand supergalaxy, an isolated island in an ever-expanding, increasingly empty cosmic ocean. This isn't just a scientific prediction. It's a profound, almost melancholic truth about our place in the cosmos. We are witnessing a slow, silent disappearance, a cosmic unseeing. The universe is revealing its true terrifying nature, an accelerating isolation where even the light from distant suns can no longer bridge the ever-widening chasm. It's proof etched into the very fabric of space-time that our dreams of intergalactic travel are not merely difficult, but fundamentally, physically, impossible for the vast majority of the cosmos. It's a silent, terrifying disappearance, a future etched into the cosmic fabric, and a stark reminder of our accelerating imprisonment. Faced with such crushing cosmic realities, the unbreakable speed limit, the accelerating expansion, the slow disappearance of entire galaxies, humanity, in its boundless, almost reckless audacity, refuses to simply surrender. If the universe has locked the doors with physics, then we, the insatiably curious, will search for a cosmic skeleton key, no matter how outlandish. This is where we plunge into the realm of theoretical loopholes, desperate gambles against the very laws that imprison us. Our first, most dazzling gambit, the warp drive. Forget breaking the speed of light. What if you could bend space itself? Pioneered by physicist Miguel Alcubierre, the concept isn't about moving through space faster than light, but about manipulating the space-time around your ship. Imagine a cosmic surfboard that creates a warp bubble around itself. In front, space is contracted, squishing the distance. Behind, space is expanded, pushing the ship forward inside the bubble. The ship itself isn't moving faster than light. It's simply riding a wave in the fabric of reality, allowing it to cover vast distances in what appears to be an instant. It's like standing still on a magic carpet while the ground beneath you folds and unfolds. The catch? Oh, there's always a catch. This audacious bet requires exotic matter, not just rare, but matter with negative mass or negative energy density, stuff that repels gravity instead of attracting it. We've never observed such a thing. It might not even exist outside mathematical equations. And even if it did, the energy requirements for creating a stable warp bubble capable of intergalactic travel would be astronomical, far beyond anything we can currently conceive, perhaps even beyond the total energy output of an entire star. It's a beautiful dream, a thrilling mathematical possibility, but for now, it remains firmly in the realm of science fiction, an incredibly high-stakes gamble against the very nature of energy itself. Next, the ultimate shortcut, wormholes. Imagine folding a piece of paper in half and poking a pencil through both sides. The two distant points are now connected by a much shorter path. A wormhole is a theoretical tunnel through space-time, a cosmic shortcut that could connect wildly distant points in the universe, or even different universes altogether. Instead of traveling millions of light years, you could theoretically step through a wormhole and emerge instantly in another galaxy. It's the ultimate cosmic bypass, sidestepping the speed limit entirely by changing the very topography of space. But here again, physics throws up colossal roadblocks, while general relativity allows for wormholes mathematically. Maintaining them open and traversable requires something truly monstrous: a massive quantity of exotic matter, the same stuff needed for warp drives, specifically arranged to exert negative gravity and prevent the wormhole from collapsing faster than a hiccup. Even if we could create one, the journey through it might be fraught with peril, susceptible to tidal forces that would tear a ship and its crew to shreds. Wormholes are cosmic quicksand, demanding physics we don't understand and materials we can't create. A desperate, audacious bet against the universe's most brutal gravitational forces. And then there's the truly mind-bending possibility: manipulating dimensions. What if our three spatial dimensions are just a small part of a larger multidimensional reality? Theories like string theory or M-theory propose the existence of extra dimensions curled up so tiny that we don't perceive them. But if we could somehow access or unfurl these dimensions, could we use them to bypass the vast distances of our familiar 3D space? It's like being trapped in a 2D drawing and suddenly realizing you can step on out of the paper into a 3D world, then back onto the drawing at a wildly different point. This isn't just speculative. It's almost entirely philosophical. We have no empirical evidence for extra dimensions beyond the four we experience: 3 spatial, 1 temporal. The technology required to even detect them, let alone manipulate them, is so far beyond our current capabilities that it verges on magic. It's a gamble that assumes the universe is far stranger, far more complex than even our wildest dreams. A desperate hope that reality itself has hidden an escape hatch in its fundamental architecture. These theoretical loopholes are not easy fixes. They are desperate, high-stakes gambles against the universe itself. Each one demands a physics revolution, an understanding of reality that currently eludes us, or the creation of matter with properties we don't even know exist. They are humanity's audacious, perhaps foolish refusal to accept cosmic imprisonment. They are the screams of our ambition against the silent, indifferent roar of an expanding, accelerating universe. For now, the universe holds all the cards, and we are left with the chilling suspicion that these are not solutions, but merely the elaborate dreams of prisoners yearning for freedom. So where does this cosmic detective story leave us? The brutal, unyielding truth, etched into the very fabric of space-time, is this: we are almost certainly, fundamentally, confined. The speed of light is our unbreakable tether. The accelerating expansion of the universe is our ever-widening, inescapable prison wall. Distant galaxies are not just unreachable, they are actively, relentlessly racing away, destined to become ghost lights in an increasingly empty night sky. Our grandest dreams of intergalactic empire, of hopping from cosmic island to cosmic island, shatter against the cold, hard physics of existence. We are, in all likelihood, forever bound to our local galactic cluster, a tiny, merging island in a universe that is sealing itself off, 1 light year at a time. But here is the profound, almost paradoxical revelation. This isn't a defeat. This cosmic imprisonment is not the end of exploration. It's the beginning of a new, far deeper kind of journey. If the universe has denied us the outward path, it has simultaneously, thrillingly, opened the inner one. The true frontier isn't across 2.5 million light years to Andromeda. It's here, within the swirling paradox of our own existence. It's in the relentless pursuit of knowledge about the very laws that bind us, the desperate quest to understand why space-time behaves this way, why light has a speed limit, why the universe expands. This forced introspection compels us to master our own cosmic backyard, to unravel the mysteries of our Milky Way, to decode the secrets of our solar system, to understand the intricate dance of life on our own pale blue dot. Perhaps the ultimate exploration isn't about covering distance, but about deepening understanding, about pushing the theoretical limits of reality, finding elegance in the constraints, and discovering that the universe's most mind-bending secrets aren't out there, but woven into the very fabric of here-T. Our prison becomes our laboratory, our confinement the catalyst for a profound inward odyssey that transcends mere travel. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion